Hi there. Slowly we are coming to the end of the lectures. Today we will be covering files, how to deal with files. But before that, I have to go through a short historical summary. In those ages, when I was young, the same age as you were, or even younger than that, we had computers, quite big ones, and operating systems. But the operating systems were so bundled with the hardware. IBM had his own, Univac had his own, Xerox had his own. And when you played around with the programming, for each operating system, you had a different mechanism to get your hands on some persistent external memory. What are those? Hard disks in those days. Still, they are existing in much smaller size. In those days, a hard disk of about 10 megabytes, I'm not spelling it, 10 megabytes was about 2 times heavier than your washing machine and almost the same size of a washing machine. The hard disk part, the 10 megabytes disks, were interchangeable, but it required 2 individuals to take it out and put it somewhere, so heavy. Then, also, for example, we had a technology which still exists, but exists in old science fiction films, where you had computers, and computer room is filled with tapes. Again, refrigerator-sized tape readers read tapes, winded them, rewinded them. It took about a couple of minutes to rewind a tape, of course. And to access these devices, these individual devices, had on every operating system a different instruction. Yes, Fortran, the language Fortran, tried to homogenize them, for example, under some numbering. 6, 5, I still remember 5 was the card readers. Go dig what a card reader is. On the Google, you can Google it. But that was on the side of the language, Fortran, for example. On the operating system, there was nothing homogenized. Then, the first attempt to sort this out, clarify this, was with Unix, honestly. Unix had an view, a more world view from top to bottom, and said that any such device is either consuming data or producing data. All your external devices are like that. Your keyboard, your screen, either consumes data, takes data and does something with it, or just the other way around, produces. For example, a keyboard produces data. In those days, it was not called a keyboard, but teletype. Then something like a tape. Oh, a tape can do it both ways. Both can be a data source when you read it, or you can write something on it, then it is a data sink. But anyway, any device, any external device is either a data source or a data sink. Okay then. Then something came to these Unix guys in their mind. We have a file system, this way or that way. Where a file system normally is something designed in those days for a hard disk or a tape or some other sort of memory, persistent memory device. They said, why not change the file system into something which holds all the information about a data source or a data set? Furthermore, why not organize these files into a tree hierarchy? This is something that you know. Your home directory at the university, at our department, can accommodate files as well as directories. And directories can accommodate other directories and other files. So it is actually a tree, an n-ary tree, because there is no limit on the branching, and each level either terminates with some file or branches again. So this is a directory. This is also a directory. If it branches, then it's a directory. If it is a single entity, then it is a file. So here we may have another directory, and here just files. Homework 1, homework 1C, homework 2C, and the 1C. For example, all your files are organized into a directory structure. You are very free in creating any node in here. You just create the file under a directory and it is there. Actually, you are adding a branch to the tree. But this is all done in a very homogeneous way by the operating system. Very nice. You can delete a directory. All this branch, all this, and whatever is below it goes away. Also, it is recycled. All these empty space is reused. so the operating system keeps track of what is cleaned and make it reusable for new allocations. Coming back to these external devices, with Unix, honestly, first we had this directory and subdirectory structure, which is very easily modifiable in the early days. Prior to Unix, it was not like that. The second nice aspect is that devices, all the various hardware devices, which, saying it again, that produce data or consume data, fit somewhere under the string. This is something new, and this is something revolutionary. There is an upper directory called /dev, which is under the root directory of your whole file system, then created by the Unix system, and under here are hundreds, sometimes hundreds of nodes. Those nodes have names. Example, TTY1. Such funny and strange namings, but when you join the game, you know that TTY1 is your screen device. When you write something that goes on the screen. Then you have others, LPT, LPT1, LPT2, etc. Some are used, some are not. If LPT is connected, if your computer is connected to a printer, then presumably this is your printer. What is a printer? It is a data sink. Sure? It's mostly a data sink. Sometimes it's also a data source. For example, it can tell you that it is run out of paper, for example. Then it sends some data to you. But some devices like the screen, for example, that is silent as a lamp, just takes some data and displays it too. We will come to this being data sink or data source. There is also another concept, which is randomly accessibility, which is definitely not the case for a printer, but the case for a screen, for example, or a hard disk. We will be talking about it later. Now, the interesting thing about it is this. In the Unix operating system, and any operating system that copies these concepts, you have directories, real files under these directories, your executable, your text files, your images, something stored in zeros and ones on some media. Even if you turn off the electricity, it lives over there, plus devices. Since the devices are very similar to real files. They provide you data, a real file. My B1C is just a sequence of characters, you know. So is the printer, so is the keyboard, so is the screen. It holds, it consumes some data, very much like a file. So the revolutionary idea of Unix is to put them under the whole, or under a single whole structure, which is a tree. What is my benefit? Or my benefit as a programmer is huge. With a single change in a C program, or even at the Unix level, at the operating system level, I can direct my output to a real file that sits on a hard disk or to a printer, and I can get a printout of it. I don't have to change lines of code in my program. I don't have to write a print to printer routine in my C program. To direct the input from one device to the other is just changing a small name in somewhere. I'll explain it in a second. So everything is homogenized under the file system, the concept of file system. This is something marvelous. For example, you are writing a missile firing system, right? Missile, you track the target and you fire a missile. When you are doing on a C system and a Unix-based system and you write it in C, it's just something like fopen the missile 1 for writing. So simple. And then let's say you write there a predetermined number, 1 for example, 5 for example, I don't know what it is, it's just hypothetical, and missile is 5. The same would be for, let's say, something else, sending something to a printer. I would do a statement as far as sequence is concerned, such a simple statement. How does the operating system know how to communicate with each different device? That is a very logical question I have to answer. Under here, there is a program sitting. You write as an operating system programmer a device, a code for the device managers. It is a piece of code. It has to have some standard functions, some standard buffers, etc. When you come to the operating system course, taught at this department, you will be taught about how you write this device controlling software. We call these device drivers. The nice thing about writing a device driver is very standardized. Can everybody write it? Well, there is nothing against writing it. If you know how to communicate with the hardware, you have to implement some functionality of the device driver, which is very well documented, and you mount your device driver with a name under the file system. And from that moment on, you don't have to worry about the device. The operating system sorts out the intermediate communication job. There are some problems on this. For problems of efficiency, we will be considering it today in the forthcoming time. Okay, now, having said this, so in your C program, you establish, this is a new term, streams, data streams, to data sinks or data producing data sources. Streams. Sometimes these streams that you establish are bidirectional. It goes two ways. Both to the device, something flows, and you can take back from that stream data. That is also possible, but basically you are laying some sort of pipes through this system, to a device or to a file. How is this done? A stream is recognized in this C program by a handle. We call it a stream handle or a file handle. Both is used. It is a pointer to a structure called file. Where does it come from? It is defined in stdioh. So if you are using this, you have to include stdioh. Nice. That is anyway, when your program is communicating with you, this way or that way, you are including stdioh. Now it is for this one as well. Now let's say I have a data on my directory. Which directory? Let's say my homework directory. I have a homework directory, and herein is a data for my homework one data, txt. It's text. It doesn't have to be. It could be an image, then it could be JPEG. Or something else, not necessarily JPEG, just as an example. I have to name this string to a variable. So what shall we say? My input. That's a variable. It is a pointer to the structure file. Where does file come? As I said, from this stdio.h. It does come. Okay then. Then what am I supposed to do? This is just allocating a pointer variable. Now you have to create a handle for the string. That is, in C, creating a pointer value and storing it in here. My input. Now comes the key function fopen. Herein goes two strings. These strings, remember, are nothing else but pointers to character sequences in the memory. So, nothing magical about it. When this gets compiled, this is replaced by a child pointer. A child pointer constant, actually. You can cook up this string in your kitchen. You can create it from several other parts using string functions and put it in here to a character pointer value. So it is not necessary to put it by this double quotes. But in our case, this means my home. Remember, this means my home. Here, under there is a HW directory, and under there, I want to get my hands on this one. Sorry, I get a little bit tight in place. So it is homework 1 data txt, comma, the second argument to fopen is also a string. A string which lets the system know about what is my intention. What could be my intention be anyway? I could read something. I could take in some data. I could produce and write something, send something to that string. I could do it both ways. I could create a node in here, a flash node, and store something, or I could use something which exists already. For example, your program does some computation, analysis, and then creates a file and stores it on the hard disk. And you do this by a C program. How will you do that? By telling to create a file from zero. There is a way to do it. All this information goes in here. Now I will go and explain what possibilities we do have over here. The first one. In here, right? We are talking about this. This is a lowercase r in quotations. Means file exists. Where does it exist? In the file structures, file tree, on the operating system. There is something like this already. It lives in its full extent, the file exists, and I want to read it. We will read it. Change some part? No, that is forbidden. Then we have W. W is something similar to this, but it says the file doesn't exist. Even if it exists, kill it. Kill all the content of it. Something terrible. Every programmer makes this mistake, this way or that way. You let a program run for maybe days, and then by accident you open up with W. You don't even touch it. You just write an F open with W, and you have killed all the formal content. So, file will be created from 0, even if it has content. The content will be gone, will be erased forever. Terrible. Then you have the third option, A, comes from append. Append is a kind of way to protect yourself against yourself. If the file does not exist at all, then append is exactly the same with W. Exactly. But if it exists, then something strange happens if you append. The file, if it exists, you cannot go to the formal content of it. The formal content is there, but you cannot go there. You start writing something or sometimes reading from this point on. This is the formal content. There is no way that you can pass this barrier and go and pitch on what was written in a prior job. Here is a barrier. For you, the 0 of the file is here. You can go write and sometimes come back and read freely in this portion. And then when you quit your program or when you close the file, when you set the stream free, then both information get unified. Then seamlessly they are all together. So when you reopen it, you can read it from top to bottom. But as long as A is effective in the fopen, you can not go and see the prior content of it. So such a file always is bound to close. Yes, that is true. An A file opened with in the append mode close always. Why is it used? In what cases? Especially when we create log files. You might have heard about a log file. A log file is a concept in computer programming of a file which keeps information about actions. For example, in this department, every 10 seconds, I would say, a mail arrives through the internet. The mail server program looks at its header and sends it to the receiver if it is in this department. So anything that goes to @CENG140 is processed by the mail server and directed to my mailbox. Also, the mail server makes a recording in a log file that at this time mail originating from this address has arrived and I have directed it to Üçoluk's mailbox. This information, not the content of the mail, but about the processing of the mail, goes into a log file. In professional life, log files play very important roles. For example, a bank teller, gişe görevlisi in Turkish, does something on the computer. Every almost keystrokes he hits is logged. So later on, if you have a discrepancy, something strange, you go to the log files, you find you write a filter, you find out all the keystrokes that teller has pressed, all actions he or she has done and maybe undone. So down to a keystroke, mostly these information are kept somewhere in a log file. An operating system keeps several logs. Actually, keeps logs of all your actions in some history file, for example. That is another log. What have you ordered the operating system to do? Log files are created by some programs. An operating system itself is a huge program written by a professional, actually a team of professionals. Log files are opened with append. All the story about logs was just to give a a concrete example of the use of append mode opening. Almost all log files, whatever you do, whatever mistake even the programmer has done, there is no possibility to erase the file, like W, or override it. You cannot see the formal content, even as a programmer. So, level gives access to the formal content if exists. You can write below it. If no formal content existed, then A is equivalent to W. Okay, now there are modifications to these. You can have a case where the file exists, it is there, you may read it, also you may change it, right? You may alter it. What to do then? For that purpose, you use the plus sign. R plus means the file exists, I will read it. Also, it is possible that I write something on the file or I grow the file from the end. So, R and writing is possible. Hocam hayırdır?
Yok, kontrol ediyoruz.
Ne diyor? Tamam hocam. Kayıttayım şu an. Okay. As you see, a plus sign is something which tells the system the other action is also possible. In reading, the other action is writing. For writing, the other action is reading. So, here the file is created from the scratch, from zero, okay, and then we write. Now, what if I go back, still while the file is open with W, and want to read what I have written? Don't think now, why shall I do this? There are reasons to do it. Now I want to change my attitude and I want to go back and read it as well. Then may decide to go to the end and write something or go somewhere else and override something formal written. Okay? But I want to also be able to read it. Then use plus. So it's W and being able to read what is written. The same is true for A. I will not explain it more. It is A, which is about creating and writing something, appending to an existing file. So it is A and being able to read what is written right now. In A plus mode, still you cannot cross this boundary. The previously created content is invisible to you anyway. Either with A or A plus, you cannot reach it. But the question is, at the end, I start writing, and I want to return to a point which is written in this session, and I want to read it. Can I do it? With plus? Yes. Now here I have a short break. We continue with additional property that you can put in here in this reading, which is something important for the professional life. Now a short break.